Okay, welcome to this weekly. This is for Algebra 1. What we would like to focus on this weekly is factoring. So reminder, in factoring we have 4 steps I want you to follow. First, check if there's a GCF. If there is no GCF, please go look for a difference of perfect squares. If that doesn't appear, look for sum and product. We also know this is the AC method. Some of you refer to it as the box method. If that won't work, then let's go with the last resort of grouping. If you look in the first example, we're looking at 2's, or 2's here and then 12 there. I think there's a GCF. There's a GCF here of 2. Okay, so what we do here is we divide every factor by 2, and what we're left with here would be, let's see, x squared. We have a minus 1x and a minus 6. Okay, reminder, you still have that GCF outside there. Okay, now inside of the parentheses, is that completely factored? No. What you would want to do is say, is there a GCF? No. It's not a difference of perfect squares. It is a sum and product type of a situation. And so let's say, what are the factors of a times c? In this case, a times c is a negative 12, that add to b, which is negative 1. And so that is going to be looking at a negative 4, positive 3, and it has to be that. So let's go with the GCF still outside there. The x squared minus x minus 6 would break down into x minus 4 times the quantity x plus 3. And if we did do distribution, double distribution, with our answer here, we should end up with 2x squared minus 2x minus 12. So please stay tuned for the question that will follow this section of the video. Okay, let's look at the second question. Again, another factoring question. Start out, is there a GCF? There is no GCF between 9 and 16. The 16 doesn't have an x, so I know there's no variable as part of a GCF as well. Is it the difference of perfect squares? Well, 9 is a perfect square. X squared is 16 is a perfect square. It's the difference of, it's the difference of perfect squares. And so the rule or the pattern that we follow here is to take the square root of the first term, the 9x squared. That would be 3x. Okay, so in our answer we would have a 3x and a 3x, because 3x times 3x is 9x squared. Now if you recall, because it's the difference of perfect squares, we will have a plus and minus. What is the square root of the second term, 16? That is 4. And so we have 3x plus 4, and we have 3x minus 4. And again, if you were to use double distribution, you would come up with 9x squared minus 16. And so I know this is our answer. So please stay tuned for the question that follows this. Okay, let's look at the third example. In this example, there is no GCF between any of the terms. This is not the difference of perfect squares. It does look like it could be the sum and product. The lead coefficient is 1. That is one of the hints that I would use to determine if it's the sum and product method. So in order to factor using that method, let's go with what are the factors of a, which is 1, times c, which is 10. So a times c is 1 times 10 is 10, sorry. What are the factors of a times c that add to b? 7. Well, you have either 1 and 10 or 2 and 5. It has to be 2 and 5 or 5 and 2. So in this case, our answer is going to be written as the s squared would break down into an s there and there. And we're going to do s plus 2 times the quantity s plus 5, and you could, switch the order of the parentheses there, s plus 5 times s plus 2, if you would like. And if you were to do double distribution there, it would come out with s squared plus 7s plus 10, so we know we are correct. So there is our sum and product example. Please stay tuned for the question to follow. Okay, let's look at this next example. Starting out here, we can definitely factor out a GCF. Looking at the GCF here, it's a GCF of 2. And so when we divide everything by 2, we would have left over 3x squared plus 11x plus 10. And put the GCF out front. You don't have to do that step. You could jump right to grouping. I feel like it just makes it easier when we go through in the parentheses to factor by grouping, because now we do have to factor this 3x squared plus 11x plus 10 by grouping. In order to do that, we have to multiply a times c. 3 times 10, that's 30. Then what we have to do is we have to come up with factors of 30 that would add to 11. That's going to be 5 and 6. I'm going to put the 6 first. The reason I'm doing that is I feel like it would go better with the 3x squared. So 3x squared plus 6x plus 5x. The 6x and 5x have to add to 11x. And then we have a plus 10. Now, this is the grouping part, so we're going to go with 3x squared plus 6x. And then over here, we're going to have 5x plus 10. Group those together. Now let's go with 2 times. Keep that 2 by itself there. I'm going to go with color coding this now. Pull out or factor out a 3x. And inside here, we're left with x plus 2. In here, I can factor out a positive 5, and I'm left with x plus 2. I have a common factor, x plus 2, which we'll call a GCF here. So this is nice. I'm going to have the 2, and I'm going to have times. If I factor out the x plus 2 as a GCF, I'm left with 3x plus 5 as my other term. And there is my answer. If I were to distribute and use double distribution, it would take me back to 6x squared plus 22x plus 20. All right, stay tuned for a question to follow this example.